means it's time for us to start. There's not a lot of us here. There's only 10 of us in this lesson today, but anyway, we'll persevere nonetheless. Just a reminder that because it is a Thursday, it means that there is a quiz at the end of the lesson. So we will stop at approximately 10 to 6, and then you will have an opportunity to go and answer those quiz questions. Okay, so yeah, I just want to encourage each and every single one of you to do that. Because it gives you feedback and it gives us feedback on how you're doing, and it also provides us a way of being able to communicate how you're doing to your parents as well. So obviously they're anxious to see that you're making progress or that you understand, etc., etc. Okay, so we encourage all of you to go and try that at the end of the lesson. Okay, and as always, Katlego and I are here to help you. We want to try and encourage you to interact with us and ask as many questions as you want. The more questions, the better. The more you interact with us, the better. So yeah, we just want to make this super interesting, super fun, and give you a better understanding of what's going on in this particular section, sequences and series. Okay, so today's lesson is about geometric series. If you recall Tuesday's lesson, we had spoken about the term formula for a geometric series, so Tn equals AR to the n minus 1. And this lesson is about summing up geometric series. Okay, so the sum formula for geometric series is here on the screen. I hope it's big enough. I can always make it bigger. This is it over here. No, maybe I should enlarge it a little bit. Right, so you will see in your textbooks at school, Matrix, that there's two different ways in which they give you this formula. So the 1 and the R can swap around. So either which way you choose to use it, it really doesn't matter. I know as far as your formula sheet for Matric is concerned, only this one is given. So that's why this is the one I teach. I don't actually even work with the other one ever. And obviously there's a restriction here as well, because we've got R minus 1 in the denominator. There's a value that R can never ever be. So R can never ever be equal to 1. Otherwise, our sum would be undefined, and we obviously can't have that. All right, so again, what is the difference between a sequence or a progression of numbers as opposed to when we now start summing? So if I've got 2, 6, 18, how is that different to 2 plus 6 plus 18? What am I doing what am I doing in the second row that I'm not doing in the first row? So this is the second row. There's the first row. What am I doing in the second row that I don't do in the first? Yes, Siatemba.
You're adding your values in the second row, while in the first row it's a sequence.
Absolutely. Okay, so it's just a collection of terms in the first row. And in the second row, I'm actually adding those terms together. Even though the second row is a series, the first term of the series, it's still going to be term 1 is 2, or A is equal to 2. This is still term 2. This is still term 3. All right, just like it was over here. There's term 1, there's term 2, there's term 3. But now, if I want to work out the sum of the first 3 terms, I can then use this formula Sn. Okay, it allows me to calculate sum to n number of terms. So that's what Sn means. Sn is the sum to n number of terms. Okay. A, as always, is the first term of your series. R is your common ratio. Remember, we calculate this by saying term 3 divided by term 2, or term 2 divided by term 1. Okay, or even if you said term 50 divided by term 49, it would be exactly the same thing. Okay, you would be able to calculate your common ratio. And n is going to be the number of terms in the series. So number of terms in the series. So that means that we're working with 4 different variables. Okay, so when we're working with 4 different variables, they can give us a combination of any 3 and ask us to work out a missing one. And we would be expected to be able to do that at matric level. Okay, so the most basic thing that they could ask you to do is just a straightforward sum. So here, where they use the word evaluate the geometric series, they're implying calculate the sum, right? And in this case, they tell us that there's 6 terms, but they also say over here sum to 6, right? So this is super straightforward, all right? We are going to just sub straight into our formula. They want us to calculate the sum of the first 6 terms. Okay, is equal to A. In this case, A is equal to 4, open brackets. R is, so in this case, it could be term 6 divided by term 5, or term 5 divided by term 4. Right, so the easiest way for you to work it out is with the smaller numbers, isn't it? So we know that 12 divided by 4 is 3, or 36 divided by 12 is 3. So R is equal to 3 in this case, to the power of 6. Now, don't get confused with a TN formula. With a TN formula, the -1 is in the exponent. Here, it isn't. Okay, so that -1 is not part of your exponent. And then at the bottom, we would have to have 3 minus 1. Okay, so when we're working with the term formula, AR to the n minus 1, the -1 is part of the exponent. When we work with a sum formula, the -1 is not part of the exponent. So a lot of matrics get muddled up with that. Okay, so I'm just pointing that out to you so that doesn't happen. And now, matrics, you can go ahead, pick up your calculator, pop that in, and work out the answer. Okay, what do you get? Okay, so Jamie says she gets 1456. There we go. Well done, Peter. Same answer. Cool, Mache. Lovely. Well done. Okay, so that's super easy. That is it would be considered an easy, good, Sukupe. That would be considered an easy level 2 question. All right, so now that I've shown you how to substitute into the formula, let's go and give you an opportunity to do this for yourself. So let's scoot down here and we'll go to our traffic lights. Okay, and the first one that you guys need to do is number 1. Okay, so here you're going to answer this question: determine the sum of each geometric series, use an appropriate formula. So the appropriate formula in this case is Sn equals A R to the n minus 1 over R minus 1. I'm going to include our term formula because we may need that later on. So both of them are there for you. All right, so matrix, try question number 1. And then as soon as you've got an answer, you can pop it into the chat and Katlejo and I can discuss it with you. Okay, so calculating the sum of this geometric series. I'm just going to go and fetch my calculator. Katlejo, I'm going to leave you in charge of helping them if there are any questions. Okay, I'm back. Sorry, I forgot to get my calculator. How are you managing, matrix? Done. Okay, cool, Jamie. Well done. I'm going to have a look at the answer now. Cool, Valerie. Nice, Coupe. Good job. Well done, that's all. And Peter. Nice, Lesedi. Good, Jolene. Good, Tumelo. I'm going to wait 1 more minute. Good, and Tebogang. Yes, Michelle, we're all having network issues this evening, so don't stress. And then there's also load shedding, so yeah, don't apologize. It's absolutely fine. Hopefully you'll be able to go and watch this at a later stage if you miss anything. Okay, so let's go and have a look at the answer. I've put the answer down here at the bottom. So that's what I got. Did you guys get the same thing? The sum to 9, I got, whoopsie. Okay, well done, Duduzile. Did everybody get the same answer as me? Maybe you pressed the SD button on your calculator. Okay, you got the same answer. Oh, good. All right. No, I was getting worried there. Perfect. Okay, if you press the SD button on your calculator, you can round your answer to 2 decimal places, or you can leave it as an improper fraction. It really doesn't matter. Okay, good show. All right, so something like this, guys, is only worth 2 marks. All right, 1 mark for subbing into the correct formula and another mark for the answer. Okay, so now let's go back up. Now we know you can all do that, and let's go and have a look at the next example. All right, that's actually very similar to the first one. I'll tell you what, let's skip that one and let's go to something a little bit more interesting. Let's go to this one here. Okay, calculate the sum of the following finite series. Now, what I want you to notice here before we get started is that I know that we've said that this lesson is called geometric summing, but you're not going to have headings in your tests and exams. Your questions are not going to come with bright sparkling lights telling you, oh, this is an arithmetic sequence or this is a geometry. They might do, but what if they don't? So you also need to read the information very carefully, and then you have to look at the series and you need to decide, is it arithmetic or is it geometric? So what would you be looking for in an arithmetic sequence? Lesedi, what would you be looking for in an arithmetic sequence?
I think we'd be looking for like a difference.
Exactly, Lesedi. All right, and I mean, if you look at these numbers here, 0,25, 0,5, 1, 2, can you see the difference is the same?
Yes, it is.
Careful. So 2 minus, so is 2 minus 1 the same as 1 minus a half?
Oh, no, it's not the same, sorry.
Exactly. No, perfect. Okay, so these are the things we need to be so careful of, Lesedi. We can see that there isn't a common difference. There's a common ratio. So 2 divided by 1 is the same as 1 divided by a half is the same as a half divided by a quarter. Okay, so in each of these cases, when we divide a subsequent term by the previous term, we end up with a ratio of 2 in this case.
Yeah.
Okay, does that make sense to everybody? Hi, Talia, welcome to the lesson, no worries. Okay, so there is a Common ratio, there is not a common difference. So if it doesn't tell you whether the pattern is geometric or arithmetic, always check that first, because then that determines which formulae we use. So we've established, number one, that this is a geometric series. The next thing that we have to ask ourselves, no problem, David, glad you could join us. The next thing that we have to ask ourselves is what are they actually asking us to do? So this question over here says calculate the sum. So in other words, they do want us to calculate Sn. But there is a problem, okay? Can anybody tell me what the problem is?
We don't know the amount of terms there are in the sequence.
Exactly. Brilliant. Who was that just spoke?
Khotatso.
Khotatso, that was perfect, right? So now that you Peter, did you want to ask something or did you want to say something?
Yeah, I wanted to say something, but she already got the answer. So.
That's fine. All right. So Peter, don't go away. I'll ask you now. All right. Can I use, cool. Can I use the formula that's on the screen to answer this question as it stands right now?
No.
Perfect. Okay. So what is the problem? I don't know.
There's no last term. I mean, there's no number of terms in the sequence.
Sorry, and I've written the wrong SN here. Sorry, guys. Sorry, I'm going crazy. This is Sn equals a r to the n minus 1. Sorry, what happened to me there? Okay, correct formula would help. The reason I cannot use this formula is, as Khotatso said, I do not know how many terms there are in this series. So I can't calculate Sn if n is also missing. So now they've given me some information to help me calculate what n is. What information have they given me? What can I use to help me calculate n so I can answer the question by calculating Sn? What did they give me?
The last term.
Exactly. They gave me the last term. They gave me the nth term of the pattern. So in other words, what they've told us is that Tn is equal to,
I don't know how this shit works, bro.
256. So in other words, 256 is equal to AR to the n minus 1. What do I need to solve for first, Matrix? I'm going to solve for
A and R.
the n.
Oh.
For the n. That's what I
Okay.
want. Okay, I want the number of terms in this series. So that means I need the a and I need the r. Do I know what a is? It's
yes, 0.25.
Exactly. So I'm going to write that as a quarter. What's r equal to?
2.
Perfect. To the n minus 1. Okay, now we're back to where we were in the previous lesson. All right, what do I need to do to both sides of the equation?
Divide them by a quarter.
Exactly. So I need to divide 256 by a quarter, or I can multiply both sides by 4. It doesn't matter. I end up with 1024 is equal to 2 to the power of n minus 1. Okay, so now my job is to write 1024 as 2 to the power of something. As it turns out, it's 2 to the power of 10. Exactly. And now that I have equated my bases, I can equate my exponents. Exactly. So if n minus 1 is 10, it means that there are 11 terms in the pattern. So I've got to do this first. Now that I know that there are 11 terms in this series, now I can calculate the sum of the series. Okay, so now I'm going to go back here and I'm going to do this. So I'm going to get rid of that. I am calculating the sum to 11. Let's get rid of A. We know what A is. A is a quarter. We know what R is. R is equal to 2. We now know what N is. So let's get rid of N and let's put in our 11. And then the only other thing that we need to get rid of over here is just the R minus 1. Okay, and then you would go ahead, pop that into your calculator, and out comes your answer. Okay, so you can share with us what you got as well, and I'll share with you what I'm getting.
Lee, just to answer, someone asked how we get it to the base of 2. So while you
sorry.
do that, I'll just tell them. So
Sure,
you type
go for
the
it.
number, you just type the number that you want on the calculator. In this case, it was 1024. And then you say equals, and then it's going to go in the answer line. Then you press shift on your calculator. You press fact. Fact is next to the hype button. It's on the left of the button that says HYP. And then it will give you the exponent. So it'll give you 2 to the power of 10. So that's how we found that. Does everyone understand how to find the exponent? You're welcome.
There we go, perfect. Okay, so yes, just use the shift fact button. Yes, in Tobogang, what question do you have?
Ma'am, can I write 0.25 instead of a quarter, or does it not matter?
Absolutely. No, absolutely, you can write 0.25. Okay, not a problem at all. Indeed, Valerie. Okay, good job. All right, so this is the part about matric that a lot of matrics struggle with, is that they don't know which formula to use. They don't know whether they should be using the TN formula or whether they should be using the SN formula. But this seems to have gone really well with you guys. Remember, 256 represents the nth term of the pattern. So in order to calculate SN, we need to know how many terms there are in the pattern. So we first got to use TN to work out the number of terms, and then we can go and sub into SN. Okay, so let's go and have a look at another question. There we go. So question number 3, matrix. You can try question 3. Or if you want to, you can try question 6. Okay, so here you've got a choice, either 3, which is a little bit easier, or if you want to go straight to a more difficult question, you can try question number 6. So either 3 or 6. Choice is yours. And of course, Katlego and I are here to help you if you need anything. Okay, and again, when you're done, just say done or give us a thumbs up. Cool, Jamie. Which one did you do? Orange or red? Since you're done so quickly, you could try the red one if you wanted to. Jamie, let's give it a bash while we're just waiting for everybody else. Okay, Kosiami, good job. Cool, Sukupe, well done. We're going to go through the answers now. Nice. Okay, so Zoom user, I'm not sure who that is. The formulae were on the screen. Good, Lesedi, well done. Maybe if I scroll up, there we go. So there's your nth term, your TN formula, your term formula, and your sum formula. I know you're not dumb. Come on, we're doing geometric summing and I wrote the arithmetic sum, so that was dumb. Cool, Jolene, nice. So I'll just wait one more minute and then we'll go and have a look at the answers and we can talk about that. And then hopefully we'll get a chance to do some sort of slightly more cool, Tumelo, cool, David, get a chance to do some sort of slightly more difficult questions if this has gone well, which hopefully it has. Okay, so here we go. All right, are you guys ready to go and have a look at the answers? All right, so here, look at the left-hand side of the screen matrix. All right, so you would have used the term formula, and you would have said 1 over 32, sorry, minus 1 over 32 equals negative 64, brackets half to the n minus 1. You would have worked out that n was 12, and then you would have calculated sum to 12. This is what I got, minus 4095 over 32. Which again, you can press the SD button if you want to, or you don't have to. Then the slightly more difficult question was like this, and I got n is 8. Are there any questions? Is there anything that you'd like to ask us?
Ma'am, can you please calculate 6 again? Because I'm a bit confused.
Sure, with pleasure. Okay, so what I'll do is I'll calculate it in this space up here. All right, so let's just go through this, right? So in question 6, they've asked us how many terms. So the question, how many terms, implies we need to calculate n of the geometric sequence, will add up to 127.5. So the words will add up to implies that the value following the will add up to, this over here, this is a SN. Okay, so it is a sum, it is an SN. Okay, so we are going to sub into our SN formula. They've given us SN, it's 127.5. So here, in place of SN, we're going to write 127.5, or you could write 127.5 if you wanted to. Then in place of A, you are going to write 64, because 64 is the first term of the pattern. Remember, we calculate R by saying term 3 divided by term 2, or term 2 divided by term 1. Okay, so in this case, R is equal to a half, indeed. Okay, and let's just get rid of that half down there at the bottom as well. Okay, so now when you are working with this, what you want to do is you want to cross multiply. So you want to multiply whatever's at the bottom over here with this numerator, and you want to multiply what's at the bottom here with this numerator. That's cross multiplying. It means you're multiplying both sides by the same thing. It gets rid of the denominator. So a half minus 1 is a minus half, isn't it? So a negative half multiplied by 127.5 leaves us with, I get, hopefully correctly, I get minus 255 over 4. Okay, is equal to 64 half to the n minus 1. Okay, after we've cross multiplied, what is the next step? We need to divide both sides by? Always by the A value matrix. Okay, so we've got to divide both sides by the 64. So leave that minus 255 over 4 on your calculator. Now we're going to say divided by 64. And I don't know about you guys, but I'm getting minus 255 over 256 is equal to a half to the n minus 1. Last step matrix, I've got to take this plus 1 over to the other side. So again, leave this on the calculator and simply say plus 1. Okay, do you get 1 over 256?
Yes, ma'am.
Do you? Okay, good. Okay. Is equal to 1 over 2 to the n. Now remember, Katlejo was talking about this the last time that we saw you. You cannot go 1 over 256 and then shift fact. Your calculator, it can't do that. So you can only put in the 256 on its own. So you press 256 equals shift fact, and that happens to be 2 to the power of 8. So the next step here, sorry, would be to say 1 over 2 to the power of 8 equals 1 over 2 to the n, and that's why n must be 8. Yes, Siatemba.
Wouldn't you just cross multiply it early on to get rid of the bases and just have them as get rid of the halves? I mean,
You can't get rid of the half because you're solving for it. Sorry.
No, what I mean is like to instead of like to cross multiply them, so you can, instead of having a fraction, you just have a proper whole number. Like for example, take 2, cross multiply it with 1, and then you have 2 over 1 instead of 1 over 2.
But is 1 over 2 the same as 2 over 1?
Do you see the first? Do you know the first step you did in the sum?
Yes, where I cross multiplied. Sure.
Wouldn't you be able to do the same thing here for 1 over 256?
No.
Okay.
No, it doesn't. Unfortunately, it doesn't mean. Oh, I see what you're trying to say. So you multiply the 2 by the 1 at the top, and you multiply the 1 by the. Oh, okay. I see what you're trying to get at here. All right. What you're saying to me is, why can't you multiply that with this, or that one with that one? That's what you're saying, isn't it? Okay.
Yeah.
So,
yes.
Yeah. So Siatemba, that's not allowed at this stage, because that is not what this means. Okay. You cannot separate the 1 over 2 from the n. Okay, because that n is the exponent and we don't know what its value is. So in this case, 1 over 2 is functioning as a base. Here, what's in the numerator and what's in the denominator, these are not bases. Okay, so the numerator here is not a base and that's not a base, right? But here it is. So when you want to solve for n as an exponent, the rule is you need to make the bases the same. And after you've made the bases the same, then you can equate the exponents. So the idea here is to write 1 over 256 as 1 over 2 to the power of 8. That's equal to 1 over 2 to the power of n. Now that the bases are the same, you can equate the exponents. And Tebogang, what's your question?
Ma'am, where you
Yes.
cross multiplied, right? Could you also not have multiplied by the reciprocal of the fraction?
Absolutely. Absolutely. So whenever that happens, you're also welcome to multiply by the reciprocal. So in other words, let me just show you what I'm talking about. Okay. So over here we had wrong pen. We had 127,5 is equal to 64. And then here we had a half to the n minus 1. And this was all over a negative half, isn't it? Negative 1 over 2. So if you want to, in Tebogang and everybody else, the other way of being able to do this, okay, is to multiply, let's do this in a different color, is to multiply this, the right-hand side, by minus 2 over 1. So I've got to do the same thing on this side. I've got to multiply that by minus 2 over 1. That way I get rid of the negative. The 1 at the top cancels with the 1 at the bottom. The 2 at the top cancels with the 2 at the bottom. And then if you do that on your calculator, if you say 127.5 times by negative 2, you get you should have got that minus 255. Did that work out?
Yes.
Okay, so you got the minus 255? Yes. Now you need to divide both sides by
64.
64. Okay, so we actually don't need that line over here. So divide both sides by 64, and we end up with a minus, which is where we were before. The minus 255 over 64 is equal to a half to the n minus 1. Add 1 to both sides, and then we can go from there, etc., etc. Does that make sense?
Yes, thank you.
Okay, it's a pleasure, absolute pleasure. Matrix, how does that feel? Thumbs up, thumbs down? Are you feeling good? Any questions? Luke, excellent question. Okay, so everybody, if you have a look in your chat, Luke has asked a really important question. And you know what, Luke, being able to work with your calculator, in other words, so what you mean and what you tell the calculator to do are the same thing. It's so important. All right, so now, if you do this, let's just move over to the side and then I can explain this over here. Okay, so now, on your calculator, you have a fraction button. Okay, right over there on the left-hand side, it's below the calc button and it's next to the square root button. So if you just press that, the idea is you can now put in a fraction, and so you can put in 1/2 if you wanted to. But let's say you want to put in the number 3.5. Now, what some students do incorrectly is they press the fraction button, they put in the 1/2, and then they put the cursor over here, and then they put in the 3. Now, the problem with this, doing it this way, you are telling the calculator to take 3 and multiply it by 1/2. That's not what 3.5 means. 3.5 means 3 plus a half. So if you want to put in 3.5, you need to press Shift and your fraction button. And then what you see will happen is that you'll get a block like that for the whole number, and then a block like that. And then, Luke, you'd put the 3 over here, toggle up with the 1 there and the 2 there, and now that means 3 plus a half, or 3.5, instead of 3 times a half. Okay, good question. Does that make more sense? Perfect. All right. So yeah, very important that what we say and what we want to have happen are the same thing. All right. So let's go back and go and see if we can do one of these difficult questions. Okay. We've worked out how many terms in a geometric series will add up to a particular number. Let's see if we can try and answer this question over here. So this is a little bit more difficult, but this is the sort of thing that your teachers should actually be doing in class with you. So theoretically, if it's seen, it's not going to be a problem-solving sort of question. If we run out of time, we can always try another one of these the next lesson, but this is solving simultaneously. So if we read the question together, it says to us, determine the first 3 terms of a geometric sequence, of which the 7th term is 1458 and the 4th term is 54. Okay, so if they want the first 3 terms of a geometric sequence, right, in essence, what they're asking for, term 1 is A, term 2 is AR. Term 3 is AR squared. So even though this question says determine the first 3 terms of the sequence, of a geometric sequence, what they really mean, what's implied by the question, is calculate the value of A and calculate the value of R. That's really what it's asking us to do. right? Now now that we know what we have to do, let's turn our attention to the information that is given to us. So information that is given to us in this way, they want us to use this information to make equations. So we need to make an equation from the words, the seventh term is 1458. Anybody got any idea how I would write that? How do I write the seventh term of a geometric pattern?
AR to the power of
Good.
6 equals
Excellent. 1450.
1,458.
Good.
Yeah.
Good. Okay, so there's a few people with their hands in the air. Gosiami, did you want to say the same thing?
Yeah, I wanted to say the same thing.
Okay, all right, awesome. So I tell you what, Gosiami, why don't you tell me what to write for the second part? So I'm going to highlight it now in green. The fourth term is 54. How should I write that?
AR cubed is equals to 54.
Excellent. Okay, and now the million-dollar question, all right? What are we going to do? This is equation number 1. This is equation number 2. What are we going to do with these two equations? How are we going to solve simultaneously? Yes, Siatemba.
And you're gonna take AR6 and AR3 to one side, and then take 1,458 and 54 on the other side.
Unfortunately not. No, that's
Okay.
not what I'm going to do. But I'm glad you said that. Let's see if somebody, Gosiami, what would you do?
I would do this by elimination. Term 2 minus term 1.
Okay, why are you saying term 2 minus term 1? I don't understand.
I'm sorry, equation 2 minus equation 1.
Oh, so you want to say equation number 2 minus equation number 1. You're getting closer. You're getting much closer. But
Ma'am, can you
okay, so now
divide
somebody else put their hand up as well. Who was it? I can't see now. Who had a hand up?
Okay. So I'm going to say equation 1 divided by equation 2.
Hey, there we go. Who's talking?
Zamambila.
Zamampile. Well done. Okay, so we cannot subtract. Okay, we cannot subtract because AR to the power of 3 and AR to the power of 6 are not like terms. So we cannot subtract. When we are talking about arithmetic problems, then we can, so where we've got two linear equations in terms of A and D, then we can subtract. But for geometric ones, we must divide. Okay, so we're going to divide the one by the other. Okay, so let's just get rid of that. It is better to put the one that has the greatest power of R at the top. Okay, so I am going to divide. That's what this line over here means. This is a divide line. So I'm just writing there, I'm dividing. Okay, now this is back to grade 8. Okay, A divided by A is 1. We've eliminated the A by division. Okay, when we divide like bases, we subtract our exponents. So we write the base. 6 minus 3 is 3. Okay, and now we've got to do the same thing with the numbers. We've got to say 1458 divided by 54. That leaves us with 27. Okay, so now we're solving for the base rather than for the exponent. All right, so what we need to do now is write 27 as a power of 3. So it can be written as base 3 to the power 3 is R to the 3. So now because your exponents are the same, you can now conclude that R must be equal to 3, this 3 over here. Okay. You don't need to create a third equation, no. You just need 2 in order to solve simultaneously. Okay, Letabo. And then, Owami, please can you share the lesson after you're done because I'm having problems with my connection. Absolutely. So you will be able to watch this later. Awami, okay. It will be available, no problem. How does that sit with you guys? Is that making sense? We're not 100% finished. Are there any questions on what we've done so far? Yes, Temba.
No, I had no question. I accidentally raised my hand.
Okay, that's fine. All right, so now remember, we've got to go back and answer the question. The first three terms of the geometric sequence, that's what they want. We've worked out what R is. How are we going to work out what A is? How are we going to calculate A, Matrix? Anyone got an idea? So we solved simultaneously. Someone said something. By substituting the R. Absolutely, Talia. Into what? Into what would you substitute it? Into one of the equations. Exactly, David. Okay, Zamampila, what were you going to say?
I was going to say that since you got R here, we divided and we got R being, then when you got the value of R, we have to take any of the equations, substitute to solve for A.
Absolutely, absolutely. So you choose which equation you want to work with. Personally, I always try and work with the equations that have got the smallest numbers, just because I think that's the easiest thing. But if you wanted to work with AR to the power of 6 equals 1458, you're very welcome. Okay, so now we're going to sub into equation number 2. So A is what we are calculating. In place of the R over here, we're going to put 3. Then we must write our exponent, which was 3, is equal to 54. Okay, whoopsie. So why is my pen doing this? Sorry, guys, hang on a second. Sorry, sometimes you just press something funny and then the whole thing goes weird. Okay, so now what do I need to do to both sides of my equation? Or maybe what I should ask is this. 3 to the power of 3 is 27. So 27A is equal to 54. So now I must divide both sides by 27. Okay, and then I'm going to get A is equal to 2. Last step. Good, Kosiami, I agree. A is equal to 2. All right, so last step, term 1 is 2 because it's A. Term 2 is A times R, so it is 6. Term 3 is AR squared. So 3 squared times 2 leaves me with 18. Okay, how does that sit with you guys? Are there any questions? Any questions, Matrix? No? Can we move on to the next one? Is that all right? Have I given everybody enough time to write that down if you were going to write it? So we've got 7 minutes left, and I thought what we could do in these 7 minutes was go and have a look at, I found some sort of slightly more difficult questions. So like question number 10 over here, or question number 8. Question 10 is a little bit more difficult than question 8. Question 8 is very similar to the one that we've just done. So if you do want to come and watch this video again, you're very welcome to come back and have a look and see whether you can do question 8 or 10. But unfortunately, oh yes, we don't have time for this because you guys have got to do the quiz. That's right. Sorry, I forgot about that. Okay, so we're going to have to stop here. And then you can go and try the quiz. And if there's anybody who wants to join Katlejo and I in the next session, which is the advanced session, you are more than welcome to do so. Okay, Matrix, thanks for joining us today. Please don't forget to go and do the quiz now. Okay, you've got to log out and log back in. All right, and then if you want to, we can join us again on in the advanced lesson. Okay, bye.
Bye, everyone.